Building the Future, Green Building in the New Millennium, brought to you by Sustainable Homes of the Future.
Yeah.
Our natural world is in crisis. Buildings emit 40% of carbon globally. We need solutions now. Join the conversation today. Welcome back to the podcast, everybody. This is Building the Future, Green Building in the New Millennium. And today, we continue our discussion of sustainability in the built environment by focusing entirely on carbon. I think it's safe to say that everybody has heard a little bit about carbon and carbon emissions. I mean, we're carbon-based life forms after all, but is it enough to drive electric cars and power our homes and buildings with renewable energy to lower our carbon footprint? Or is there more that we can do to avoid climate catastrophe? We're here to answer that question and many more. My name is Ian Sollenberger, and joining me as always is the CEO of our sponsor, Sustainable Homes of the Future, Ginger Matthews. How is everything, Ginger?
You're doing great, Ian, and welcome to our faithful listeners. So glad you're here with us today. Today's episode on carbon is an important look at the negative environmental cost of building with materials that are manufactured using traditional carbon-intensive processes, and that's what we want to eliminate here. So it's estimated that buildings in the building industry account for over 40% of global emissions. Yet, the focus these days tends to be on electric cars. Transportation is important, but in order to really mitigate the climate change crisis, we need to reinvent how we design and construct buildings for the health and survival of our planet. So we talked last episode about the ins and outs of net zero energy design, which puts energy efficiency at the top of our list of project goals and aims to eliminate what we call operational carbon in all new and existing buildings.
Okay, that's a term, operational carbon. Can you explain what that means?
Well, burning fossil fuels like natural gas, liquid petroleum, coal, heavy oils to produce energy for operating our buildings produces emissions that end up in our atmosphere and can stick around for a long time, just like our gas guzzling cars, very much the same concepts. Greenhouse gases, or GHGs, are made up of more than 80% carbon and often referred to simply as carbon emissions. So unless we stop burning fossil fuels, reduce our collective carbon footprint drastically over the next 30 years, we're looking at some really, really damaging changes when it comes to weather patterns and the survival of our fellow humans and planet.
Yeah, no good. Until recently, I'd actually been under the impression, not that recently, a couple years back, that we had gotten rid of greenhouse gases way back in the 90s when we were told we needed to stop using those terrible CFCs and save the ozone layer. But I'm now kind of learning that that was a bit of a red herring at the time. It really only dealt with a few specific gases that we knew were harmful then. And now we know more about the long-term effects of carbon dioxide in the atmosphere. And the information is out there on the internet for all to see. So game changer.
Great. So, Ian, if I'm already driving a Tesla and I live in a solar powered energy producing home, you're saying there's more I could do to be lowering my carbon footprint. How would I do that?
Well, the tough part is that there's not really that much that the average person can do beyond advocating for change. The real next step involves a dynamic shift in the building design and construction industry as a whole. If we leave it up to the folks in charge right now, things may change over time and move in the right direction, or they may not. And that's why we're here having this conversation. That's why we're trying our best to spread the word about the industry overhaul required to flatten the curve, as it were, when it comes to carbon emissions and environmental toxins. And it all comes down to, drum roll please, embodied carbon.
Okay, so can you define embodied carbon for us?
Of course. The definition of embodied carbon that I'd like to start with here is the, quote, true cumulative emissions of any product, or in this case, a building, including the extraction of materials from the ground, transport, refining, processing, assembly, in use, and finally, end of life profile. So, you know, it's certainly a big step in the right direction to deal with the in use, or as you said, operational carbon of a building. But as you can see from that definition, the carbon produced to operate a building is only a portion of the emissions that are produced over the entire life of that building and its parts. For instance, just because you're driving a Tesla doesn't mean that there weren't emissions in the making of that vehicle that unfortunately still contribute to the degradation of the environment. And different from operational carbon, which we can reduce over time through these strategies that we've been talking about, embodied carbon is here to stay. Once it's created, it does not go anywhere.
So we need to consider the hundreds of materials required to create the building and all the emissions that went into the manufacturing and transporting those materials to the site.
Yeah, exactly. Not an easy task by any means.
Not at all, but we are going to give it a try here. We're going to absolutely give this a try. So we'll be focusing our next podcast episode on building materials. So obviously, tune in for that one. We'll be highlighting innovative ideas in building materials with lower carbon footprints, even some materials that are known to trap and contain carbon from the atmosphere, which is really, really exciting.
Ooh, sequestration.
Yes.
That's a fun term. Yeah, we'll get to that next episode. I guess I lied earlier a little bit when I said that once the embodied carbon's out there, that it doesn't go anywhere. Because you're right. If we can trap carbon, if we can sequester carbon, we can get some of that. But we're still, we're still
back up.
Yeah. Cool. And what should we know when it comes to measuring carbon in our buildings? Is there a process for that?
Well, there's an industry term called life cycle assessment, and that considers, the carbon emissions for the cradle to cradle life of a product, and it's quickly becoming a green building industry standard. It's really being talked about a lot in the industry. So these assessments and corresponding environmental product declarations, or EPDs, encourage less ecological impact for projects mindful of embodied carbon and the adoption of new ideas and methods for the manufacturing of common building materials. But we may strongly remind you that sustainable or high-performing buildings are still estimated to be only 1% to 5% out there of the overall building stock in the U.S. so far. So our aim is to educate the building community, and so that percentage increases by a lot.
Yeah, it's a stark reality when you look at the numbers. I mean, we're so still a long way off from the goal of net carbon zero, which, by the way, is defined very differently depending on whom you ask. Just like net zero energy's sorted past, we talked about last episode, net zero carbon has yet to really settle on an agreed upon definition. The World Green Building Council hasn't really come around to including embodied carbon in their definition of zero carbon or carbon neutral. So that's questionable, right? I mean, how are we going to, if we're missing, embodied carbon, and we're still calling it zero carbon or carbon neutral, it's not really accurate. But there are some other organizations out there that do include embodied carbon in their definitions. So that's good.
That's great. Yeah, it's coming online, just like a lot of these new technologies and ideas about sustainability. So can you talk a little bit more about who's leading the charge when it comes to embodied carbon?
Yeah, I'd love to. Super excited about a program that actually started back in 2006. That's how long we've been talking about these issues, and most people still don't know about them. There was a research nonprofit called Architecture 2030, and they issued the 2030 Challenge January of 2006 to everyone in the building industry, and they laid out some energy reduction benchmarks to sort of pave the way for a sequential path towards zero embodied carbon by 2040. So they're actually shooting for 2040. Everybody else is saying, 2050 is the date, but they're saying, no, if we're going to do this, we really have to, put the pedal to the metal here. The first steps to doing that are the ones that we talked about last week, reducing operational carbon. But the work's not done until the entire industry gets on board. And we need help from lawmakers to urge these, stragglers to do just that. Big shout out to Architecture 2030 and the American Institute of Architects, the AIA, for committing to the 2030 Challenge, and for all the trailblazers in the industry who have been considering these issues, as I said, for almost 15 years, and have been working diligently since then to inspire other people to join the cause.
So if you're interested in learning more about these terms and some of the programs and organizations committed to tackling the embodied carbon issue, check out the Carbon Leadership Forum's website at carbonleadershipforum.org. So in conjunction with a large construction company called Skanska, a company you might have heard of called Microsoft, and a number of other industry partners have an open source calculator that was developed to access embodied carbon emissions for various building projects. So the tool is called EC3. Out there, it's been developed and tested, so it's ready to go. Embodied Carbon for Construction Calculator is what is the full name. And it was incubated at the Carbon Leadership Forum. So cool. Definitely worth a mention for bringing design folks a way to accurately measure embodied carbon and partner with manufacturers to procure low carbon products in their building design. So it's finally here. We've been seeing it come in for a while, and so we're really happy the industry is going to be embracing this software.
Yeah, and unlike a lot of the other modeling programs out there, it's actually open source, as you mentioned, which means everybody can use the tool. So that's then leading to more transparency across the industry. And one thing we've been wanting to focus on more, we've been talking about this every episode, is like, how do we hammer home all electric construction? We talked last episode about the cost and the energy savings associated with switching from gas-powered appliances and water heaters to electric heat pump water heaters, savings equivalent to 13 million vehicles driving for a full year. Building all electric helps us avoid having our buildings powered by dirty energy in a big way, but it also brings us a real opportunity to talk about some of the other problems with fossil fuels. Do you want to take that one, Ginger?
Certainly. When it comes to greenhouse gases, most of the focus is on carbon dioxide. But let's not forget about methane as well, which is created from burning natural gas. If your home or building has gas lines, you can pretty much assume some level of methane leakage, sometimes estimated at more than 5%, which is exponentially more damaging to the health and environment.
Yeah, so obviously carbon dioxide is bad. Carbon emissions are way more prevalent. But what you're saying is that methane is actually more concentrated, and so it's harmful even in smaller quantities, right?
Yes, that's right.
How do we know that for sure? Is there some sort of standardized way that we can measure how ecologically harmful different greenhouse gases are?
Yes, there is. There's a term, global warming potential, that comes up with a number to measure the cumulative effect of any gas on the planet and all the impending issues we're trying to avoid from carbon dioxide in the atmosphere.
Yeah, so for instance, if methane is, let's say, 20 times more potent than carbon dioxide, right? Then 5% leakage ends up being a 100% problem. Easy math, until we get rid of gas altogether, which is why that we're so focused on all electric construction. It's really the only way to get rid of both the health and the ecological concerns related to methane gas in the atmosphere, which we now realize can't be ignored. Not many people know that indoor air quality can be greatly affected by gas leakage, in addition to the high cost of building out the infrastructure. So you're paying a premium with health, you're paying a premium ecologically, and you're paying a premium money-wise as well. That's only going to go up. So in summation, it's time for gas to go. That's what I think.
Goodbye. Yes, if we go all electric in the building sector, that creates a perfect scenario for the grid to be 100% renewable energy. And that's a goal we should all be shooting for. And that's what I'm excited about in the future. So what do you say to anyone who says they can't live without their gas range? Seems like an uphill climb when you're talking to someone who really loves cooking over gas. Yeah. In fact, my daughter's an avid chef, and there's almost a pride that comes from getting burns on your arms in the chef world. And, there's something aligned to being wonderful, this gas that they use for cooking. And I can't convince her otherwise right at the moment. So.
Well, maybe like toxic masculinity, it's time for that pride in natural gas to kick the bucket. There are plenty of professional chefs that have already made that switch to electric induction cooktops. And for anyone that hasn't used one since the 80s, they've come a long way since your grandmother's, electric.
The electric, yes. Well, actually, it was you who challenged me to buy one and
Yeah.
use it. And when we first started talking about this whole thing, and I just, well, what the heck? It's, $60. I'm going to give it a try. Don't like it. I'll throw it out. But turns out there were a lot of other benefits in addition to lowering emissions. So you can set the temperature, achieve more consistency with the induction range. You don't need the vent, and there's a lot less pollution in the kitchen going on. I actually have an air quality measuring machine there, and I can see that it's really improved. So
that's great.
Perfect for professional chefs. Really, it can be. It takes a little getting used to, but anyone looking to standardize their cooking process, they're going to have a really good experience with induction cooktops.
Yeah, you can set, let's say you're making a caramel or something. You can set the temperature, so the milk doesn't scald. It'll stay the same temperature the whole time. Mm-hmm. It's exactly. So at the end of the day, all we're really recommending is that anybody that's curious about all electric homes and buildings, purchase one of these high-end induction cooktops and try it out. They range anywhere from about $20 to $30 on the low end. We don't recommend those. Spend the $50 or $60, or I think the high end, maybe there's like $100 version. But try it out. You might end up being pleasantly surprised. Who knows?
I think you will. At least I have. So you said earlier there's not much the average person could do if they don't work in the building industry, but there has to be something we can all do, right? Any ideas, Ian?
Yeah, I do have a few. First things first, we got to get more involved at the local level and reach out to city council members, state legislators, explain to them how important our health and the health of our planet actually is. You and I have started conversations with the planning department here in Santa Monica, and I think there's a real opportunity to help push these ideas to the forefront, similar to the way that racial justice has finally made it into our global awareness in a big way. So we need to be advocating for climate justice as well. Within our lifetime, we're going to find out whether we can turn the tide on climate change. And it really begins by being more realistic about the level of commitment and legislation required to do so. I'm not, somebody who's always about, big government. But I think in this case, like I've said in earlier episodes too, like you need the carrot and the stick. Incentives alone aren't gonna do it, I don't think. Over the next 30 years, this is something that really, was a big revelation for me, that over the next 30 years, embodied carbon in new buildings will actually outweigh operational carbon due to the number of buildings required to house our quickly growing population. So because we're going to be building so many buildings, that embodied carbon, we're really ramping up the amount of embodied carbon that we're about to release into the atmosphere. So now is that time that we need to change this.
Great point, Ian. So we need to get the word out, which is exactly why we started this podcast. And what's the other one? You said you had a few ideas? Yeah,
I've got one more, sort of a general one, I guess. But, we can buy products from companies, do the research. We can buy products from companies that are committed to efficiency, carbon neutrality, even if they have nothing to do with our buildings. When we put our money toward companies that share our values and our goals, then we further those ideas in a big way. So to kind of sum up today's episode here, because we talked about a lot of terms were thrown out there. Here's my summation. Carbon, other greenhouse gases in the atmosphere have been shown to have a huge effect on the health of our planet. Experts and scientists, overwhelmingly tell us that we have about 20 to 30 years to really sway the tide. And during that time, we're battling two equally important fronts: operational carbon and embodied carbon. There have been some really promising strides made in reducing carbon in the operation of our buildings and encouraging renewable energy sources for use in buildings, but that's really only half the battle. Embodied carbon, released during the extraction, manufacturing, distribution of these materials that make up our built environment, is the silent killer in this very important climate change equation. And the conversation has just begun. So we need to get the word out. keep saying that, but it's true.
Yes, we're trying to do that. So, and all you can subscribe to our podcast, please do on Apple, Spotify, or Google Podcasts, Google Play, I think they call it, and share the conversation we're having with anybody that you can. So you never know what kind of influence someone may have as an investor, board member, employee, or even just friend of someone making these sustainable building decisions. We want to influence the discussion. So thank you all for joining us today. And as I mentioned earlier, next week's episode, we will all be talking about avoiding materials in your building that contribute to climate change. So right. There's a lot of great ideas out there, and we can't wait to explore them with you.
Please feel free to reach out to info@shfbuild.com with questions, comments, suggestions of other topics to explore when it comes to best practices in green building and in sustainable design. And yes, please tell your friends about the podcast. Share the link, subscribe, follow us, contribute, just listen, whatever it is you feel inclined to do, whatever you can do. We appreciate your help. Thank you, Ginger, for another solid episode for sure.
My pleasure, Ian. Thank you, listeners, for tuning in to our podcast. See you next time.
Yes, thank you, fellow green building enthusiasts, for listening to Building the Future. Until next time, start the embodied carbon conversation, whether you're in the building industry or not, because together we can build a future that works for us all. Building the Future, Green Building in the New Millennium, brought to you by Sustainable Homes of the Future.